Part 3. Adding and subtracting fractions with like denominators. Now we're ready to add and subtract the easy fractions, the ones where they already have common denominators, like 1/7 and 4/7 will make 5/7. Another way of looking at this is saying one of these plus 4 of these makes 5 of these. Another example is 5/9 plus 2/9 is equal to 7/9. As before, 5 of these plus 2 of these gets me 7 of these. That's it, except for reducing, of course. What if we had something like 1/10 plus 7/10? We know that to be 8/10. These cannot be reduced because there are no numbers that will divide into top and bottom evenly, so 7/9 is my answer in this case. However, with 8/10 I can divide top and bottom by 2, and that would evenly go in 4 times on the top and 5 times on the bottom, giving us 4/5 as a final answer. Let's try adding two mixed fractions, and you can already see that I've written them with the miracle of editing. We can change these into improper fractions if we wish. The way we do that, 4 times 2 is 8, plus 1 is 9, and this number would be 9/4. 4 times 4 is 16, plus 1 is 17/4. And now you notice that we have two fractions with a common denominator. My answer will be in fourths. The numerator, 9 of these plus 17 of these makes 26 of these. Now this would be my answer, except we must always look to see if we could reduce. I think we can all see that these are both even numbers, and we can divide the top by 2, giving us 13, and the bottom by 2, giving us 2. Now 13 divided by 2 could be our answer, and that's perfectly acceptable. However, our original problem was given to us in mixed numbered form, whole numbers and fractions. So it wouldn't hurt us to take the 2 and long divide it into the 13 and get us 6 and 1/2. So that's another way of writing this. Both answers are correct. Now we can do this either by using the improper fraction method, or we could also do it this way. If we put 2 1/4 on the top and 4 1/4 on the bottom, we could add 1/4 to 1/4, giving us 2/4, and 2 and 4 makes 6. The 2/4 is a fraction which is reducible. Both of these can be divided by 2, yielding 1 on the top and 2 on the bottom. So if we take the whole number from the first part and attach our new reduced fraction to it, we get 6 1/2. Notice that both answers must be the same because we've used the same logic. We could either do it improper or using mixed fractions. What if I wanted to subtract fractions with like terms, like 3/8 minus 1/8? Well, as you could probably guess, we would do it exactly the same way as addition. Instead of adding the two numerators, what we will do is take 3/8 and subtract 1/8, yielding 2/8, or 3 of these minus 1 of these is 2 of these. But as before, we must always look out for reducing fractions. So in this case, both top and bottom are divisible by 2, and when we divide, our final answer becomes 1/4, and that's how we would easily subtract fractions. But what if we have something like a mixed number, 4 3/8 minus 1 5/8? We can easily do this if we decide to go to improper fractions. In this case, we never have to borrow. So let's try this with improper fractions. 8 times 4 is 32, and 2 make 35/8, and then I want to subtract. 8 times 1 is 8, and 5 is 13/8. So as you can see very simply, we have a common denominator. We have 35 minus 13. which is 22, and our final answer is 22/8 unless we can reduce, which we certainly can. Both top and bottom are divisible by 2, and we get 11/4. Now we have a choice of either writing it as an improper fraction, which is reduced, or we could divide 4 into 11, and that will give us 2, which is 2 3/4. Both answers would be acceptable. 2 3/4 might be a little bit better, but notice how we're avoiding the pitfalls of borrowing using this horizontal method and finding a common denominator as an improper fraction. Let's try the same problem again, but now we'll use this vertical method where we want to subtract 1 5/8 from 4 3/8. We start with the fraction. Can we take 5/8 away from 3/8? And the answer is no, there's not enough eighths. So what we'll do is we'll borrow 1 from the 4, leaving us with 3. Now this 1 will slide over and become 1 3/8. Now what can we do with this? Well, we can make this into an improper fraction. 8 times 1 is 8, and 3 makes 11/8, just as before. So we have 11/8, and we want to subtract 5/8, so that should give us 6/8. The whole numbers are very easy to do. 1 from 3 makes 2. Our final answer is 2 6/8, unless it's reducible, which I think we can all see it is, and we can divide top and bottom by 2, and this fraction becomes 3/4. So we'll take the whole number from the front and our new reduced fraction, and we get 2 3/4. If we compare this to the way that we've done this before, you notice that this answer is exactly that answer. So we should be able to do it either by improper fractions or subtracting it vertically. Now, in a similar way, whether we have to add or subtract, here's an addition problem using the exact same fractions. What if I had 5/8 and I wanted to add it to 3/8? 5 of these and 3 of these gets me 8 of these. And we have 1 4 makes 5. Interestingly enough, not all fractions stay fractions. In this case, we have enough eighths. 8/8 is the same as 1. Any number divided by itself is 1. So we have the whole number from the front, which is 5, and let's add it to our whatever fraction we have, which there's none, but it is a whole number, and 5 plus 1 is 6. And that's how we add and subtract like fractions.